So the first thing is the behavior of the electron. The electron is going to be treated as not something that's spinning around in orbits. It's something that will exist in an orbital, that it will be randomly buzzing around. The negative charge will be distributed in certain areas around the nucleus. So those certain areas could be double shaped. The negative charge is distributed in this way, or the negative charge of the electron is as a negative charge of the electron is in a d orbital. Okay, so the electron will be existing or occupying spaces around the nucleus, and its negative charge will be distributed in either the s, p, d, or f orbital. फिर हमने किया था कि the s orbital has only one type because there's no direction. The p orbital has three types, which depends on the orientation. That the negative charge of the electron could be located on the x-axis, so it might be distributed on the x-axis, it might be distributed on the y-axis. So depending on which axis around the nucleus the negative charge is located, you'll have px, py, and pz orbitals, right? Up at d, the negative charge of the electron, if it's distributed in the d orbital, so it will be in 5 different orientations, and there will be 5 different types of d orbitals. Up at f ka kya tha, there would be 7 different types of f orbitals. So that is how the negative charge is distributed around the nucleus. Up here we talked about subshells. I told you that it's a group of degenerate orbitals, which is the same type of orbitals. You'll have px, py, and pz. These are degenerate orbitals because they are exactly the same type, except that the direction in which the negative charge is distributed is different. They'll have an s subshell. It will have only one s orbital. The p subshell will have px, py, pz. D will have 5 different d orbitals. F will have 7 different f orbitals. If you talk about the p subshell, this entire thing is the p subshell. One orbital can have a maximum of 2 electrons. The negative charge of 2 electrons will be distributed over here. So the negative charge of 2 electrons will be distributed in the py. The negative charge of 2 electrons will be distributed in the px. The negative charge of 2 electrons will be distributed in the pz. So around the nucleus, if you're standing on the nucleus, that's your p subshell. और फिर d जो है ना वो इन सारों को combine कर लो. So then we talked about shells. I told you that shell is nothing physical. It's just the energy of the electron. That if you have an energetic electron in an orbital or subshell, the electron will occupy spaces much further away. That the electron will be very energetic, so it will be buzzing around in areas. If it's even more energetic, the electron will be much further away from the nucleus. So what happens is that as the electron gains energy, and the energy levels are quantized, it's always gaining a very specific amount of energy. It's not it can gain any energy. It's always a very specific amount of energy. So what happens is that the electron moves further away from the nucleus. It occupies areas much further away from the nucleus. So ये सब क्या था? Up here we talked about minor details, but we started talking about how. So what was important was we started talking about how do you figure out in which subshell are the electrons distributed. So what we did was, you've got the Aufbau principle, which is you make a table 1s, 2s, 3s, and then you follow the diagonal arrows this way. So every atom, the electronic configuration is going to be written like this. Like starting with the first one. So अगर मैं इसको draw करूं, just 1 second. ठीक है, so we did. So if I draw aluminium, it's going to look like this. That aluminium will have. तो आपने बस इसको order को fill करना है. Aluminium is 13 electrons. 1s will have 2. The second shell s orbital will have 2. The p subshell will have 6 electrons. The 3s subshell will have 2, and the p subshell will have. You'll just be left with 1 electron. So aluminium को अगर मैं draw करूं, it's going to look like this. That right around the nucleus, there would be 2 electrons. The negative charge of 2 electrons will be will be found over here, ठीक है? अच्छा, फिर you've got 2s2, which means there's going to be a bigger orbital or subshell, and the negative charge of 2 electrons will be distributed over here. So these electrons will be more energetic because they are in the 2s subshell. As if 2p miss 6. 2p means there are 3 orbitals. Okay, so they're going to be so 2 electrons with their negative charge will be distributed on the x-axis. 2 electrons, their negative charge will be distributed on the y-axis, and 2 electrons, their negative charge will be distributed on the z-axis. So that is 2p6. Then you have 3s. 3 means it's even more energetic, but it's an s. So that means there are 2 electrons, and their negative charge will be distributed in a much bigger space. So 2 electrons, the ones as you can see the screen, their negative charge will be distributed in this entire bigger space. They'll be even more energetic. अब 3p के अंदर 1 है. 3p means you've got 3 orbitals, but only one of them has 1, so it could be any one of them. 3px, let's call it. So there's 1 electron which will be in the its negative charge distributed on the 3p1. So aluminum would kind of look like this. It would be kind of messy. 2 electrons in the first shell. So the negative charge right around the nucleus, the electrons will not be very energetic. I said, no one is going to ask you to draw this. I'm just trying to show you a picture of this. वो एक draw करने वो कह सकते हैं. Either they might ask you to draw 2s, that's it. I said 2s का मतलब है there's a second shell s orbital and the negative charge of 2 electrons distributed in this black region over here. 2p6 means 2 electrons over here, 2 electrons over here, 2 electrons on this axis. CS means 2 electrons which are even more energetic and they're occupying spaces much further away from the nucleus. CP1 means that you've got 1 electron in a p orbital. 6 आ सकते हैं because you've got other axes as well, but right now you just have one of them. ठीक है? So you got these orbitals. Now this is very similar to what you have studied already in O levels. O levels where you just had neat circles, that's it. You get 2 electrons, 8 electrons in the. So you had 8 electrons. And then you had 1 electron in the. So then you had 1 electron in the last subshell. Okay? So this is exactly, sorry, not 1, 3. Aluminum case where there's going to be 3. So you can see that the outer subshell, the 3 electrons buzzing around, 1 on this axis and 2 in the 2s. So it's exactly the same. Okay. अगर मैं इसको mark कर रहा हूँ, first shell, this is the second shell, 8 electrons, and the outermost shell, that's 3 electrons. But remember to keep this in mind. We'll still be using this diagram, but that's how electronic configurations will be written now. Okay? Or so that's how electronic configurations will be written, and बाकी सब कुछ वही है. ठीक है? अच्छा, जिन्होंने मिस किया, I'll send the lectures. ठीक है? देखिए क्लियर है बाकियों को? Is this clear?
जी सर.
साथ समझ आए ये? I think last class में नहीं थे.
Yes.
So basically just remember this part. And I told you that once you have written down electronic configuration, make sure you correct the order. So अच्छा किसी बड़े atom की electronic configuration देख लेते हैं, how to write that. periodic table का है. किसके 37? Just iodine. Iodine is 53, I think. You will confirm if iodine is 53. Let's try and write the. So let's try and write the electronic. I think it is 53. So let's try and write the electronic configuration of iodine based on the table over here. So just start following the arrow. Iodine has 53 electrons. So the first one, that's 1s2. 1s2 के बाद क्या होगा? That's 2s2. Then you have 2p6. Remember the p has. Remember these are subshells. P has 6 electrons. ठीक है, मैं फिर से वो highlight कर लेता हूँ कि p का क्या मतलब है कि when it has 6 electrons, that means 2 electrons buzzing on one axis, 2 electrons buzzing on the other axis, 2 electrons buzzing the negative charge buzzing on the z axis. Okay, so you got 3 p orbitals. That's a p subshell. So it's going to have 6 electrons. So you got 2p6, right? As a 2p6 के बाद you have 3s2. Okay, keep following the arrow 3s2, and then after 3s2 you'll have 3p6, 4s2. Okay, 3 4s2. 4 means the electron is now much further away from the nucleus, right? Then you'll have 3d10. Okay, remember the d subshell has a total of 10 electrons. How many electrons do we have? That's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 38. We count 4p6. What's after 3d10? That's 4p6. Then you have 5s2. Has somebody counted how many electrons we've got so far? 4, 10, 12, 18, 20, 30, 36, 38. As a 38, 4D आता है उसके बाद. 4D will be 4D10. So that is 48. And after 4D, you'll have the last arrow, that's 5p. And just 5 electrons in that. Okay, so all I've done is I've just copied it. And make sure once you're done, make sure you correct the order. I mean, it's better to, although it's throws away a irrelevant step, but it's always good to. But once you've written down the electronic configuration, okay, just 1 second. Just correct the order. Order कहाँ पे correct करना? I think I have to switch the 4s and 3d positions. Okay, so I'll according to shell number, and I have to switch the 5s and and 4d positions. So ये and 4d. I said now the order is correct, but only do it once you've already written down the electronic configuration. So that's it. That's iodine's electronic configuration. Like अगर वो shell wise करना ना, it's kind of the same thing. It's the same O-level stuff. The first shell will have 2 electrons. The second one has, in this case, 8. Okay, so you got 2 electrons, then you got 8 electrons. The only thing is they're distributed in a different way. Okay, you've got 18 electrons in the third. और फिर यहाँ पे कितने? That's I think that's 18. And the last outermost shell has 7 electrons. So that's how. So the outermost electrons in the fifth shell, which are the furthest away from the nucleus, they've got 7 electrons. Okay. So that's how electronic configurations are going to be written. And इसका एक और example कर लेते हैं कि you'll start noticing some similarities now. ठीक है, basically electronic configuration, all you have to do is
बंद कर रहा हूँ ना
just follow this table. ऐसे कैमरा ऑफ कर. अच्छा, so you just hold on a second. अच्छा, writing electronic configuration, ये वाला part तो हो गया. Now what we want to do is we want to start just practice a few more. Let's say I take another group 5 element fluorine, that's 9 electrons, right? The fluorine ka kaam aasan hai, that's just follow the arrows. The first one, 1s, will have 2 electrons. The 2s will have 2 electrons, and the 2p will have 5 electrons. Okay, that's it. So that is what fluorine is. Okay, arrows ko follow karna hai, 1s2, 2s2, and then 2p5. That's about it. So the similarity in electronic configuration within groups, that's this. The first shell has 2 electrons. The second one has a total of 7 electrons. तो यहाँ पे वो properties भी देखिए नजर आ रही हैं कि how do you, अच्छा properties भी नजर आ रही हैं कि every group 7 element has 7 electrons in its outer shell. ठीक है, अब now there's one thing, that is that writing electronic configurations is kind of time consuming. तो एक चीज पे move कर लेते हैं कि how do you just write electronic configurations without actually going into that much detail. तो एक चीज याद रखना कि O levels में भी यही होता था कि अगर आपको group number पता ना, if you know that something is in group 1, you know that its outermost shell has 1 electron. If it's in group 2, you know its outermost valence shell has 2 electrons. बल्कि तो ये क्वेश्चन कर लेते हैं, how to write electronic configurations quickly. One thing, remember this, that when we look at an atom, we're not interested in what's going on in here. We're not interested कि अंदर वाले shells में क्या चल रहा है. What we are interested in is this outermost shell, जो furthest away electrons. These are the ones that are involved in bonding. The electrons that are really far away, that are very energetic. They're the ones that will interact with other atoms, and these are the ones that will either get lost or they will gain or they will start sharing electrons. So bonding में जो involve होंगे, it's these electrons, the outermost shell electrons, right? So we're not really interested in the inner electrons. ये अंदर जो भी 1s2, 2s2 में चल रहा है, we don't care about that. ठीक है? In the case of aluminium, we only care about what's happening in the outermost shell. ठीक है? तो that will determine what the chemical properties and the way it's going to chemically bond with other atoms. So I'm not interested in the whole electronic configuration. So how do you write electronic configurations quickly? So the answer to that is बस group number देखो जो levels में होता था. Just look at the group number and you'll know the valence electrons. So for example, if something is in group 1, as if something is in group 1, that means its outermost shell will have just an S and it will have one electron in it. And you can try, as you can try any. ये इसका valence shell है, just ऊपर लिख भी देते हैं. अच्छा, so अच्छा, without even writing the electronic configuration, you know the outermost shell has a S and it's got one electron in it. वो करके देख लो. It's if I do potassium, that's example would be potassium. Let's do potassium. That's 19 electrons. So if I start writing the electronic configuration, it's going to be 1s2, then 2s2, then 2p6, then there's going to be 3s2, and then 3p6. Okay, that's 18 electrons, or 4s1. So the outermost electron is in the fourth shell, and that's an S. It's got one electron in it. Okay. So anything that's in group 1, उसकी पूरी electronic configuration लिखने का फायदा कोई नहीं है. End में you're going to get an S with one electron in it. ठीक है? ये clear है?
जी सर.
Sir.
As similarly, you've got group 2. Group 2 will always be S with 2 electrons in it. Any element in group 2 will have the same, let's say beryllium, 4 electrons. So 4 electrons will be 1s2 and 2s will be 2. The outermost make it's got an S subshell with 2 electrons. Even if you try some other element like magnesium. Magnesium is 12. So it's going to be वही आएगा. It's going to be 1s2 and then it's going to be 2s2, then it's going to be 2p6. And then there's going to be 3s. So S ही आ रहा है with 2 electrons, and so on. We can just keep on doing this. It's if an element is in group 3, so the outermost shell will have S2 and P1, and we did aluminium. Aluminium को अगर देखोगे ना, तो it's उसका outermost देखो, it's S2 and P1. Shell number abhi humne figure out kiya, but it's S2 and P1, right? That's the outermost shell. That's the valence shell. So we can go on. It's we'll have group 4. As a group 4 will be S2 and P2. Group 5 will be S2, P3. As a group 6 will be S2 and P4. Group 7 is going to be S2 and P5. And your noble gases will be, अच्छा, तो group numbering में सही कर लो, it's going to be S2 and P6. Okay, that's how the electronic configuration of the valence shell will work. अच्छा, plus also remember that up से ना your new periodic table, that's it's there's no group 3, it's actually group 13. Okay, similarly there is group 14. Where you have you've got 15 and then 16. but it's the same group, but there's a one letter in front of it. You get 17, and then the last one is actually 18. Okay, just remember this, that instead of calling it group 3, it's actually group 13. Or 7 is not 7, it's actually group 17. Okay? It's the same thing, but one add हुआ है. And the reason they did that was कि कहाँ है आप लोगों का pivot table, just a second. I see your pivot table. I just wanted to show you your pivot table. Okay. But what they did was the 13, this is group 3 actually. They just numbered the transition metals. Okay, first group, second group, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then becomes 13. So it's kind of your 3 is now actually 13. Your group 4 is actually 14. Okay. इतनी कोई confusion की बात नहीं है. बस वो one add हो गया, that's about it. अच्छा, वापस उस पे आ जाते हैं कि ये part clear है कि how to quickly write the electronic configuration. Is that clear? This one.
जी sir.
ठीक है.
Yes sir, but I have a question.
Yes.
Could we signify which element is which, because
नहीं, आवाज नहीं आ रही.
simply write. Sorry.
ये क्या कह रहे हो?
Saying ke how would we signify which element is which element if we write the shorter form? For example, for potassium, we write S1. So should we add the shell number also, so that we know that this is potassium?
नहीं, अब मैं उसमें आता हूँ, shell number पे आता हूँ, ठीक है. अच्छा, the purpose of this was I just wanted to know कि what is the outer shell electronic configuration. That's it. ठीक है. जैसा वो नहीं होता group 7 में हमेशा outer valence shell में कितने electrons होते हैं? 7 होते हैं, ठीक है. We did a couple of group 7. The outermost, it's S2 and P5. This one is S2 and P5 as well. अच्छा, how do you know the shell number now? वो क्या होता था? How do you figure out the shell number in O levels?
Period number.
ठीक है. So the shell number is basically equal to the period number. So not only can you figure out the outermost subshells, but you can also figure out the period number as well. Okay, for example, I've got bromine. So bromine का क्या होगा? Bromine कहाँ गया? Where's bromine? Bromine is in fourth. Where is? As a bromine is first period, second period, third, or fourth. Here, this is bromine. So bromine is in the fourth period. As a bromine group 7 में तो उसको नीचे कर लेते हैं. So bromine's outermost shell is going to be 4s2 and 4p5. That's what bromine would. So that's what bromine would be. Our complete electronic configuration लिख के भी देख लो. Bromine is I think 35 electrons, so that's 1s2. 2s2 35 ही होता है ना. हाँ जी.
सर 4s2 के बाद 3d आता है ना.
हाँ.
तो सर वो क्या तरीके है?
मैं लिख रहा हूँ ना 1s2 2s2 2p6. ठीक है. 2p6 के बाद क्या आता है? 3s2. Then you have 3p6. Then you've got 4s2. Then you have 3d10. And then you have 4p5. Order मैंने कहा था correct the order, ठीक है. So if you correct the order, the reason I'm not talking about 3D is I just want to know what's the outermost shell.
Okay.
Clear? The outermost shell is S2 and P5. Fill करते हुए I did fill 3D. Actually, remember the order of filling is irrelevant. वो तो एक table है ना, I just want to know the electronic configuration because you're never actually filling electrons in an atom. वो atom में electrons are already filled, right? So the order of filling is irrelevant. You just follow those arrows, that's it. वो बस एक trick है to figure out what the electronic configuration is, which is why at the end, make sure that you put them in the right order. ठीक है? So that's your valence shell. और वही आया, ठीक है, 4s2 and 4p5. अच्छा, plus, so the thing is, no need to write complicated electronic configuration. अगर ये tellurium है, if this is in group 6, so that means its outermost electronic configuration is S2 and P4. And if it's in group 5, so it's going to be 5s2, 5p4. If something is in group 3, its outer electronic configuration like anium, that's वो कर भी लेते हैं anium की electronic configuration. 49 की वैसे लिखना शुरू करो, it's going to take a long time. So we are S2P1, so it's in group 3. The outermost shell is 5s2 and 5p1. That's what indium is. So 3 electrons in the outermost shell. अच्छा, अब ये कि we know the shortcut. We know that we can figure out the shells as well. अच्छा, then there are different ways of writing electronic configurations. एक तो मेरे ख्याल से वो box notation में पहले I did the box notation. So different ways. Of writing the same electronic configuration. So let's there are different ways of writing electronic configuration. So the first one is that's number 1. I'll just write one electronic configuration. We're going to follow how we can कोई छोटा atom choose कर लेते हैं. Let's talk about krypton. I said let's do this one. So one of them is the box notation, right? As a box notation, we've already done that. Okay, 1s is then 2s. 2p is going to be bigger in size. Here you have 3s, then 3p. And then the last one is 4s. Okay, every box 1s has 2 electrons. 2s has 2 electrons. 2p is full as well. पहले वो single manner में fill होगा, and then so that's full. So this one is full as well. Okay, each box represents one orbital, and then you have 4s. That's just 1 electron. Okay, so that is the box representation, and sometimes the box representation is energy wise be given of that. Okay, they might 1 second. So उसमें the same boxes can be arranged according to the अच्छा, according to the energy. कि 1s 2s की energy उससे ज़्यादा है, then you have got 2p6, then you've got 3s. ठीक है, these energy levels are increasing, so the boxes could be on an energy axis. Okay, 1s lowest energy, then 2s and so on. So then there's another version which is that what is also done is, इसी पे खत्म कर देते हैं कि Krypton has, हर दफा अगर आपको, you have to code the electronic configuration, it's going to take a long time, right? So what you do is you look at Krypton and you look at this fact कि there's a way of, इसको copy कर लेते हैं. अच्छा, you look at Krypton, or sorry, Krypton कह रहे हैं, ये potassium है. अच्छा, you look at potassium and you try and figure out where potassium is in the periodic table. अच्छा, potassium जो है ना, it's right over here. So what you do is, potassium is 19. तो आप देखते हो कि 18 इलेक्ट्रॉन्स पे कौन बैठा हुआ है, उससे पहले नोबल गैस. So this is writing electronic configuration using noble gases. Argon is 18. So what you do is, क्या वापस जाते हो पोटेशियम पे and you figure out कि भाई ये जो 18 electrons है ना, the first 18 electrons, that's the electronic configuration of argon. तो आप कहते हो चलो ये argon है और उसके बाद फिर end में 4s1 है. यानी write the electronic configuration of argon and then add 4s1 to it, you'll get potassium. ठीक है, that's 18 electrons. 18 electrons is, so 18 electrons is argon. अच्छा, so what you do is you use noble gases to write the electronic configuration of elements. तो वो थोड़ा shorter हो जाता है, ठीक है. Instead of writing all of this, it just means के write the electronic configuration of argon and then put 4s1 at the end. So kind of easier to write this stuff, ठीक है. कि बार बार अगर if you have to write the electronic configurations, you can just do this, ठीक है. ये clear है?
जी सर.
Yes, sir. What is another example for this in another letter?
किसी का भी ले लो अगर उस पे.
After argon.
Let's do magnesium, right? As a magnesium is 1s2 2s2 2. So if I go and have a look at magnesium, right? अच्छा, तो magnesium is over here, it's 12. Magnesium से पहले 12 electrons. 10 electrons is neon, right? So what I can do is, I know कि magnesium. So what I can do is, I know that this part is neon और फिर उसके बाद there's 3s2. Clear? So write the electronic configuration of neon, that's 10 electrons, and then put CH2 in front of it. ठीक है, is this clear?
Yes.
और फिर वही आप ब्रोमीन के लिए कर सकते हो. ब्रोमीन से पहले क्या होगा? It's going to be, ब्रोमीन से पहले ना argon आता है. That's 18. Like if you go all the way before bromine, 18 electrons is argon. So 18 will be up till this point, I think, CP6 तक. So bromine will be, this part will be 18 electrons, that's argon. And then you put CD10. And 4p5. ठीक है, ये क्लियर है? और बाकी ये कि अच्छा, बाकी I'll share the, वो शेयर किए मैं, I think I'll share the lectures again. Just make sure you go through them, ठीक है?
Sir, I have a small question.
हाँ जी.
Why do we add the 3d10 if the outermost shell is only needed to be specified? like in the case of bromine.
पहली बात है, if you just want to know the outer shell, there's no point for 3d10, right? ये तो मैं कह रहा हूँ, this is the shorter version of that because 35 से पहले ना सिर्फ argon आता है. You use noble gases to write electronic configurations. So the only option is
Okay.
18 electrons is argon, so 3d10 में से बीच में fit करना पड़ेगा. But the thing is, if you just want to know the outermost shell, you don't even have to write the electronic configuration.
Okay.
You just know that it's S2P5, ठीक है?
Right.
चलो ठीक है. तो next time बात करते हैं, ठीक है? Okay.
Okay, Allah Hafiz.
That is it.